Okay, so I would like to formally welcome you guys to our revision course for physical sciences. We're going to be working together for for the remainder of this course, and we're going to be treating various topics. And our first lesson for today is going to be an introduction to momentum. You guys did this topic earlier in the year, and I'm sure it's something that you are quite familiar with. So our learning outcomes, our learning objectives for this lesson is that at least by the end of this lesson, at the end of this video, you should be able to define what momentum is and also be able to calculate the momentum of a moving object. So let us just get straight into it without wasting any time. Um, what is momentum? How do we define momentum? So momentum in short refers to, or at least what is referred to as linear momentum, refers to is a vector quantity equal to the product of the mass and velocity of the object. So the symbol for mass is m, as you know it, and the symbol for velocity would then be v. So momentum only applies to moving objects. For example, if a car is moving, so we show that it's moving by writing doing that arrow, which is just be the velocity. So it only applies to moving objects. In fact, momentum can be regarded as mass in motion. Mass, which said it's m, and it's in motion. So if it's in motion, it has a velocity v. So remember now, if you recall what you did earlier this year, you remember that the formula for momentum would then be P equals to mv. This would be momentum, and this would be the mass, as we have mentioned, of that object, and then this would be the velocity. In this formula, it's important to know that the momentum is a vector quantity, mass is a scalar quantity, and velocity is a vector quantity. In the next lesson, we're going to talk more deeply about what is a vector quantity and what is a scalar quantity. Another thing that is important to note here is that momentum P is directly proportional to, so P is directly proportional to the mass of the object, and also the momentum is directly proportional to the velocity. But what does this mean? This means that if we increase the mass, if the mass of an object increases, it will result in an increase in momentum. If the velocity, the same thing, the velocity of the object increases, it will result in the increase of momentum. Subsequently, if the mass of the object has to decrease, the momentum will also decrease. Same thing here, if the velocity of the object decreases, the momentum will also decrease. So this means that if we have, for example, if we compare two cars, say we have a car here and another car, and then on these are similar cars, and then if, for example, we decide to put a block of mass on this car, so this car now has a larger mass. This means that the momentum of this car will be much bigger than the momentum of this car. And as well, if you have the same cars, and then this one maybe is moving at a faster speed than this one, or at a faster velocity than this one, then this one will then have a higher momentum. So that is what it's meant when we say that momentum is directly proportional to the mass and also directly proportional to the velocity. An increase in mass or velocity will result with an increase in momentum. A decrease in mass or velocity will result in a decrease in momentum. So, let us just try to put everything into perspective by taking a calculation. So we have a question in front of us, and it says that consider a car of mass 2000 grams with a velocity of, so there's the mass with a velocity of 8 meters per second east. Then we calculate the momentum of the car. So the first thing that I would say is that for step 1, we have to determine the direction. So we given, they saying, so we know it's going to be east or west. So let's say this is east, and then this direction is west, and this direction is east. And we have to now decide that, okay, let's say east is going to be positive, and then west is going to be negative. So it's important to determine which direction is positive and which direction is negative. That is our first step. And then we have this car. So I like drawing schematics of whatever the question is saying. It helps me think. So this car, they say, with a mass of about 2000 grams, is moving at that velocity, and that velocity they're saying it is how much? 8 meters per, that's a mistake, so it's just 8 meters per second. Okay, cool. So then the next step would then be to say step 2 would then be to list all the given quantities. List given quantities. I know my handwriting is terrible, but yeah, so what is it that we know? Okay, we know that they've given us the mass. They said it's 2000 grams. They've given us the velocity. They said it's 8 meters per second. So because velocity is a vector, it means that we have to include the direction. So we said it's moving east, and we said east is positive. So this thing will just remain positive 8 meters per second. Remember, you don't need to write that positive. I'm just writing it there for convenience. And then step 3, I would say, is just to make sure that everything is in SI unit. So that is step 3. So you have to convert. If you look at your mass here, it's given in grams, but you know the SI unit for mass will be kilograms. So we have to now convert. We have to convert this mass to kilograms, and you know that to do that, we simply have to say that mass, which is 2000, my apologies, and you divide it by 1000, and that would give you about 2 kg. So if you want to convert from grams to kilograms, you know, you simply divide by what is it, by 1000. So our mass in actual fact is 2 kg. And then we see, okay, we have the mass, we have the velocity. This means that we can be able to calculate the momentum using our formula, and the formula for momentum is given by P equals to mv. So okay, we have m, we said it's 2, and then it's the product of velocity. That velocity is nothing but 8. 2 times 8 is nothing but 16. Remember, the SI unit for this is kg, the SI unit for velocity is meters per second. So this is going to be 16 kg meters per second, which is the unit of measure for for momentum. So we're actually able to answer that question. But remember, in physics, you always have to report. So you have to say, okay, therefore, the momentum of the car is 8 kilometers east. No, I'm lying. 16 kilograms meters per second east. So that is the momentum. That is not clear. Let me just erase that. So we have 16. Just running out of space. That's why I'm writing it there. We say it's east because we see that at the end here, our answer is positive. And we said that positive is east, and momentum is a vector. So when we report that answer, we also have to include that direction. So our answer becomes 16 kilograms meters per second east, and then you would have found your answer. Okay, so moving right along. So while we are talking about momentum, then we can also talk about something called a change in momentum. And we know when we talk about a change, we always write it with delta. And we said the symbol for momentum is P. So that's going to be a change in momentum. So the formula for change in momentum would be like this. So we would have a change in momentum. So, but before we actually go to the formula, let me just describe this situation here. So we have a change in momentum when we have an object. So imagine this is like a ball, and it's being thrown at a wall. This is a wall, and then it's moving at a specific velocity. We call that initial velocity vi, and then it hits the wall and then it bounces back, hits the wall and then bounces off the wall. And when it bounces off the wall, it will move at a different velocity, and that velocity we call it vf. And this, in this scenario, we're going to have a change in momentum written as delta p. So a change in momentum, like I said, so we have a change in momentum would be, okay, we'll consider the final momentum. We'll call that PF minus, because it's a change. So we subtracting two things. We're subtracting the final momentum with the initial momentum. We're subtracting the initial momentum from the final momentum. But then we know that the formula for momentum is P is mv. So we'll have m, the final velocity here, minus m, and then we have the initial velocity that ball was moving with. And then it's just a simple maths here where we say, let's take out a common factor, which is m, and then we are left with vf minus vi. And I think this is the formula that you are most used to. Then you can write it as change in p, the change in momentum, equals to m multiplied by the change in v. So vf minus v1 would be a change in v. So that is the formula to calculate a change in momentum. But then let us now do another calculation that requires us to use this formula. Okay, so we have a question here. They say, consider a tennis ball with a mass of 0.1 kg that is thrown and strikes the floor with a velocity of 5 meters per second. And they say it's downward. So because it's velocity, it's a vector, they also have to include the direction. And bounces back at a final velocity of 3 meters upwards. And then the question wants us to calculate the change in momentum. So how do we go about doing that? Like I mentioned earlier, the first thing we have to do is the direction. So we have to say, okay, let's say upwards would be positive. So positive is for upwards, and then negative would be for downwards. It doesn't have to always be this way. If you like, you can always say, okay, I want my downwards direction to be positive and my upwards direction to be negative. So it really doesn't matter which direction you pick. So that's our step one. And then the second thing we have to do is that you have to now list all the given quantities. What is it that you know? We know the mass, we given the mass, which is 0.1 kg, and then we given the initial velocity. That initial velocity is 5 meters per second, and they said that it is downwards, and we said that downwards is negative, so this is actually going to be minus 5 meters per second. Remember, this I just means initial velocity, and then we have the final velocity vf, and they said that the tennis ball hits the floor and then bounces back. So it bounces back at a velocity of 3 meters per second. And then they say it's going upwards. So we said upwards is positive. So this will be positive 3 meters per second. And then we know that now our formula for change in momentum, we said that the change in momentum, so we said that, let me just put this in a box. So we said that the change in momentum is given by m vf minus vi, where this is the final velocity of the object and this is the initial velocity of your given object. So we look, everything is in SI units. This is the mass is in kg, the velocity is in meters per second, so we don't need to convert anything in this case. So we say the mass is 0.1, and this is just a quick calculation, and then vf is 3, vi is minus So remember, we have the minus in the formula, so we now have to include this minus here from, because it's the direction of downwards of the initial velocity, so that will be minus 5. And then if you do this calculation, you put it in your calculator, you're supposed to come to an answer of about 0.8 kilograms meters per second. And then you'll find that this answer is positive. If it's positive, it means it's upward, so the change in momentum. So therefore, the change in momentum equals to 0.8 kilograms meters per second upwards. And yeah, this brings us to the end of this lesson. Remember what we did. We just defined what is linear momentum. You need to be able to know that definition. We also calculated the momentum of a moving object, and we also calculated the change in momentum of a moving object. Remember, like I mentioned, if you have any questions after watching this lesson, you take any questions that you might have or comments, and then we can discuss them when we meet next week Monday.